Robotics. What IT is, how it works. What is robotics? Robotics is the intersection of science, engineering and technology that produces machines, called robots, that replicate or substitute for human actions. Robots perform basic and repetitive tasks with greater efficiency and accuracy than humans, making them ideal for industries like manufacturing. However, the introduction of artificial intelligence in robotics has given robots the ability to handle increasingly complex situations in various industries. What is a robot? A robot is a programmable machine that can complete a task. While the term robotics describes the field of study focused on developing robots and automation, each robot has a different level of autonomy. These levels range from human-controlled bots that carry out tasks to fully autonomous bots that perform tasks without any external influences. How do robots work? Some robots are pre-programmed to perform specific functions, meaning they operate in a controlled environment where they do simple, monotonous tasks, like a mechanical arm on an automotive assembly line. Other robots are autonomous, operating independently of human operators to carry out tasks in open environments. In order to work, they use sensors to perceive the world around them, and then employ decision-making structures, usually a computer, to take the optimal next step based on their data and mission. Robots may also work by using wireless networks to enable human control from a safe distance. These teleoperated robots usually work in extreme geographical conditions, weather and circumstances. Examples of teleoperated robots are the human-controlled submarines used to fix underwater pipe leaks during the BP oil spill, or drones used to detect landmines on a battlefield.
Pros and cons of robotics. Robotics comes with a number of benefits and drawbacks. Pros of robotics: increased accuracy. Robots can perform movements and actions with greater precision and accuracy than humans. Enhanced productivity. Robots can work at a faster pace than humans and don't get tired, leading to more consistent and higher volume production. Improved safety. Robots can take on tasks and operate in environments unsafe for humans, protecting workers from injuries. Rapid innovation. Many robots are equipped with sensors and cameras that collect data, so teams can quickly refine processes. Greater cost efficiency. Gains in productivity may make robots a more cost-efficient option for businesses compared to hiring more human workers. Cons of robotics. Job losses. Robotic process automation may put human employees out of work, especially those who don't have the skills to adapt to a changing workplace. Limited creativity. Robots may not react well to unexpected situations, since they don't have the same problem-solving skills as humans. Data security risks. Robots can be hit with cyber attacks, potentially exposing large amounts of data if they're connected to the Internet of Things. Maintenance costs. Robots can be expensive to repair and maintain, and faulty equipment can lead to disruptions in production and revenue losses. Environmental waste. Extracting raw materials to build robots and having to discard disposable parts can lead to more environmental waste and pollution. Future of robotics. Future of robotics. The evolution of AI has major implications for the future of robotics. In factories, AI can be combined with robotics to produce digital twins and design simulations to help companies improve their workflows. Advanced AI also gives robots increased autonomy. For example, drones could deliver packages to customers without any human intervention. In addition, robots could be outfitted with generative AI tools like chat, resulting in more complex human-robot conversations. As robots' intelligence has shifted, so to have their appearances. Humanoid robots are designed to visually appeal to humans in various settings while understanding and responding to emotions, carrying objects, and navigating environments. With these forms and abilities, robots can become major contributors in customer service, manufacturing, logistics, and health care, among other industries. While the spread of robotics has stoked fears over job losses due to automation, robots could simply change the nature of human jobs. Humans may find themselves collaborating with robots, letting their robotic counterparts handle repetitive tasks, while they focus on more difficult problems. Either way, humans will need to adapt to the presence of robots as robotics continues to progress alongside other technologies like AI and deep learning. Types of robotics. Humanoid robots. Humanoid robots are robots that look like or mimic human behavior. These robots usually perform human-like activities like running, jumping, and carrying objects, and are sometimes designed to look like us, even having human faces and expressions. Two of the most prominent examples of humanoid robots are Hanson Robotics Sophia and Boston Dynamics Atlas Cobots. Cobots, or collaborative robots, are robots designed to work alongside humans. These robots prioritize safety by using sensors to remain aware of their surroundings, executing slow movements and ceasing actions when their movements are obstructed. Cobots typically perform simple tasks, freeing up humans to address more complex work. Industrial robots. Industrial robots automate processes in manufacturing environments like factories and warehouses. Possessing at least one robotic arm, these robots are made to handle heavy objects while moving with speed and precision. As a result, industrial robots often work in assembly lines to boost productivity. Medical robots. Medical robots assist healthcare professionals in various scenarios and support the physical and mental health of humans. These robots rely on AI and sensors to navigate healthcare facilities, interact with humans, and execute precise movements. Some medical robots can even converse with humans, encouraging people's social and emotional growth. Agricultural robots. Agricultural robots handle repetitive and labor-intensive tasks, allowing farmers to use their time and energy more efficiently. These robots also operate in greenhouses where they monitor crops and help with harvests. Agricultural robots come in many forms, ranging from autonomous tractors to drones that collect data for farmers to analyze. Microrobotics. Microrobotics is the study and development of robots on a miniature scale. Often no bigger than a millimeter, microrobots can vary in size depending on the situation. Biotech researchers typically use microrobotics to monitor and treat diseases, with the goal of improving diagnostic tools and creating more targeted solutions. Augmenting robots. Augmenting robots, also known as VR robots, either enhance current human capabilities or replace the capabilities a human may have lost. The field of robotics for human augmentation is a field where science fiction could become reality very soon, with bots that have the ability to redefine the definition of humanity by making humans faster and stronger. Some examples of current augmenting robots are robotic prosthetic limbs or exoskeletons used to lift hefty weights.
Software bots, or simply bots, are computer programs which carry out tasks autonomously. They are not technically considered robots. One common use case of software robots is a chatbot, which is a computer program that simulates conversation, both online and over the phone, and is often used in customer service scenarios. Chatbots can either be simple services that answer questions with an automated response or more complex digital assistants that learn from user information. Robotics applications. Beginning as a major boon for manufacturers, robotics has become a mainstay technology for a growing number of industries. Manufacturing. Industrial robots can assemble products, sort items, perform welds and paint objects. They may even be used to fix and maintain other machines in a factory or warehouse. Healthcare. Medical robots transport medical supplies, perform surgical procedures, and offer emotional support to those going through rehabilitation. Companionship. Social robots can support children with learning disabilities and act as a therapeutic tool for people with dementia. They also have business applications, like providing in-person customer service in hotels and moving Products around warehouses. Home use. Consumers may be most familiar with the Roomba and other robot vacuum cleaners. However, other home robots include lawn-mowing robots and personal robot assistants that can play music, engage with children, and help with household chores. Search and rescue. Search and rescue robots can save those stuck in floodwaters, deliver supplies to those stranded in remote areas, and put out fires when conditions become too extreme for our firefighters.